everyone. The purpose of this video is to help you learn to simplify when dividing radical expressions. Now, about the easiest situation that we could have is a situation like this. The square root of 4/9. When you have the square root of a fraction, you are allowed to take the square root of the top over the square root of the bottom. So you would have the square root of 4, which is 2, and the square root of 9, which is 3. So the square root of 4/9 is 2/3. Well, what do we do if we have something like this? The square root of 3/16. Well, the square root of 3/16 would be the square root of 3 over the square root of 16. That would be the square root of 3 over 4. There is no square root of 3 that's a whole number or a rational number, so we're just going to leave it as root 3. We're not going to type it into our calculator and get a decimal. We're just going to leave it as root 3. Now here's where things get interesting though. What if the fraction had been the square root of 16/3? This is where we have trouble. Again, it's the square root of 16 over the square root of 3. That would be 4 over the square root of 3. Remember, the square root of 16 is 4, but the square root of 3 does not break down. This situation is not good. We do not like to have radicals in our denominator. So no radicals are allowed in the denominator. Now, notice this one was not a problem. This one was not a problem because the radical is in the numerator. You are allowed to have radicals in the numerator. You are not allowed to have radicals in the denominator. So, what are we going to do about that? Well, to get rid of that radical that's in the denominator, we are simply going to multiply the top and the bottom of the fraction by the square root of 3. Now, why would we do that? Well, we've already discussed that when we multiply a radical times a radical, oh, that was in another video in case you didn't watch it. When we multiply a radical times a radical, we would get, we just multiply the radicands. So that would be the square root of 9. And the top would just be 4 times the square root of 3. Now the good news is, what's the square root of 9? Well, the square root of 9 is 3. So this problem became this problem, which became this. That radical's not allowed, so we multiplied the top and the bottom by the square root of 3, and we ended up with 4 root 3 over 3. Little side note. I know there's a 3 here, and there's a 3 here. But this guy is under the radical, this guy is not. You are not allowed to cancel unless both numbers are either under the radical or not under the radical. You cannot cancel if one of them is under and one of them is not. All right, let's try another one of those. How about something like the square root of 2/5? Well, again, that would be the square root of 2 over the square root of 5. Neither one of those simplifies. I am not at all concerned about the square root of 2 in the top, but I am very concerned about the square root of 5 in the denominator. So how will I fix that? Well, I will do exactly what I did here. Only instead of multiplying by the square root of 3, I will multiply by the square root of 5. Now, what will that give me on top? Notice these are both under radicals. So when I multiply them, I will get 10 under the radical. The square root of 2 times the square root of 5 is the square root of 10. Notice in this previous example, I did not multiply 4 times 3. I couldn't because the 4 was outside and the 3 was inside. Here we have the square root of 10 over the square root of 25, which is just 5. Now again, somebody is going to be tempted to cancel 5 into 10. Of course we want to cancel 5 into 10, but we can't because the 10 is under a radical and the 5 is not. Therefore, that is the answer to the question. All right, let's try another one. Let's try the square root of 13 sevenths. All right, here we go. The square root of 13 sevenths. That would be the square root of 13 over the square root of 7. Now, the square root of 13 does not bother me at all, but I surely don't like that root 7 in the denominator. So how will I fix that? You know, we're going to do exactly what we did here and exactly what we did here. Only this time, we will multiply the top and the bottom by the square root of 7. Now, these are both under radicals, therefore I will multiply them together and get the square root of 91, if I do my arithmetic right. And on the bottom, I'm going to have the square root of 7 times the square root of 7, which would be the square root of 49, which is 7. Again, we're not even going to think about canceling because this is not under the radical and this is. All right, let's try, how about something like this? Now, this is a little bit different. You will notice that in the denominator of the fraction, you have a difference. You have something minus something. Not just a plain number, which is what we've had in all of our other examples, but now we have like something minus something. Or it could be something plus something. When that's the case, we have to proceed a little bit differently. If you have a binomial term down here, that is, if you have something plus something or something minus something, you need to multiply the top and the bottom by what we call the conjugate. That word may be familiar to you, and maybe not. The conjugate for 2 minus root 5 is 2 plus root 5. In general, the conjugate of x plus y is x minus y. And the conjugate of x minus y is x plus y. So obviously I don't have x's and y's in my problem, but the idea is, since this is x minus y, my conjugate will be x plus y. And you have to multiply the top and the bottom by that. So before, we were multiplying the top and the bottom by just the radical, because that's all that was down there, so that was fine. But as soon as you put this kind of expression down here, you're going to multiply the top and the bottom by the conjugate. Okay, so what happens here? Well, on top, we have a distributive thing going on. So this is going to be 3 times 2 plus 3 times the square root of 5. So I'm just going to use my distributive property, and I'm going to multiply 3 times 2, and I'm actually going to multiply them and get 6 because they're not under radicals. They're both not under radicals. Here I have a 3 and a root 5. I'm not going to make that 15 because the 3 is out and the root 5 is in. Now what about down here? Well, let's see what happens. This is kind of cool. This is going to be a FOIL situation. Remember your foiling? First, outside, inside, last. This is going to be a FOIL. So here we go. First times first. They're outside the radical. I'm going to multiply them together. I'm going to get 4. Outsides plus 2 root 5. Because the 2 is out, the 5 is in, I cannot multiply those together, plus 2 root 5. Minus 2 root 5. Again, the 2 is out, the 5 is in. They can't be multiplied together to make 10 or anything like that. It's just minus 2 root 5. Those are my insides. And now my lasts. See how they're both under radicals? I can multiply them together then and get 25. So it's going to be minus the square root of 25. I'm out of room here. I'm going to come over and erase a little bit. So let's see what I end up with. Okay, so here's where I am. I'm transferring over here. So here's what I've got. I've got 6 plus 3 root 5 over, all right, now what's in the bottom? Well, the square root of 25 is 5. So on the bottom, I have 4 plus 2 root 5 minus 2 root 5 minus 5. Again, when I multiplied my radical 5 times my radical 5, I got radical 25, which is 5. Now, what do you notice about these guys? Do you notice that they cancel? That's really good news, folks. Really good news. Because remember, we don't want radicals in the, oh, I erased it, but we don't want radicals in the denominator. So we had a radical in our denominator. This was our original problem. We had a radical in the denominator. It's gone. So we have 6 plus 3 root 5 divided by 4 minus 5, which is negative 1. Now, I probably wouldn't count that wrong, but real big people, mathematicians, don't write that. When you divide by negative 1, it just changes your sign. So negative 6 minus 3 root 5 would be the best way to write that answer. Wow, that was a lot. Let's try one more of those. And then I have one other problem I want to do. And then you'll be ready to practice some of these on your own. All right, so let's try one more of these. How about 2 plus, or no. How about 2 over 4 minus root 3? All right, now, sometimes we multiply by just the radical. We can't do that this time because we have a minus in our problem. So this is going to be one where we need the conjugate. Anytime we have a plus or a minus, x plus y, x minus y, anytime we have that kind of situation in our denominator, we're going to use the conjugate. So what is the conjugate of 4 minus the square root of 3? It's 4 plus the square root of 3. Now in the numerator, we're going to distribute. So 2 times 4 and 2 times root 3. Now I feel like I'm repeating myself a lot, but I want to emphasize that when we multiply 2 times 4, we're going to go ahead and get 8. Because this is not in a radical, this is not in a radical, it's a regular multiplication problem. 2 times root 3, we don't make a 6. We have 2 radical 3. Because you cannot multiply a number outside a radical with a number inside a radical. Now on the bottom, here we go. We're going to FOIL. First, 4 times 4. Outsides, plus 4 root 3. Insides, minus 4 root 3. Are you getting excited? That's supposed to happen. That's why we do this. We want these guys to cancel and get rid of that radical. So we did first, outside, inside. Now I have to do last. Square root of 3 times the square root of 3. Now it's going to be negative because it's negative radical 3 times positive radical 3. So it's going to be minus the square root of 9. I multiply the 3 and the 3 because they're both under radicals. So now I have 8 plus 2 root 3 over 16 minus 3. So my answer is 8 plus 2 root 3 over 13. One more. Let's consider simplifying this. Well, after what we just did, this is an easy one, but you'll see why I want to do it in a minute. Are we going to need the conjugate here? No. There's no plus or minus. This is just 4 divided by the square root of 2. So do you remember the first few examples we did? How do we handle that? We multiply the top and the bottom by just the radical. So what does that leave me with on top? 4 root 2. How about on the bottom? The square root of 2 times the square root of 2, which would be the square root of 4. And the square root of 4 is 2. Now take a look at that for a minute. We have not been able to cancel in any of our problems so far, but this one does cancel. Not the 2's. I'm not going to cancel the 2's because I'm not allowed to cancel something inside with something outside. I have to cancel either both numbers outside or both numbers inside. So what have I got here? Do you see this right here? Both of those numbers are outside the radical. So 4 root 2 divided by 2, I can cancel the 4 and the 2, and my answer then is just 2 radical 2. I know I said that was the last one, but let's do one more of those just to make sure we got a handle on that. So why don't we try 6 over root 6. Now, don't you dare try to cancel now. Outside, inside, can't cancel. But we do have a radical in the bottom. We do know what we need to do. We're going to multiply top and bottom by the square root of 6. So that will leave me with 6 radical 6 on the top. And on the bottom, since these are both inside the radical, underneath the radical, I can go ahead and multiply them together and get 36 under the radical. The square root of 36 is 6. So now I have this. I got 6's all over the place. Do any of those 6's cancel? Not that one. Do not cancel that one. He is under the radical. But what about these? They are outside the radical, so they will cancel each other out, and my answer is 1 root 6, which big kids write as root 6, just radical 6. And that's the answer to the question. Okay, now if you want to do some practice problems, there are some posted. This is called simplifying radicals in the denominator, division of radicals. So have fun.